Hey, and welcome back to Dealing with Technical Debt. Welcome to Lesson 3. In the first two lessons, we've talked about defining exactly what we mean by technical debt. We've talked about some different causes that can lead to technical debt being present in our system. And we also talked about a scale of technical debt ranging from accidental to deliberate. And we also briefly talked about how sometimes technical debt can be a good thing if it allows us to meet a deadline, perhaps to get some funding or get approval that allow us to deliver the more stable, bigger, more robust system. Or perhaps it could be good to avoid over-engineering something early on so that we can get real feedback from our code being out in the wild before we then iterate on it, improve it, and remove this technical debt. But do so in a way that you've actually got real feedback that will allow us to shape our solution in the right direction. So, now that we know we have technical debt, what I want to do now is move on to talking about how we're going to start dealing with that technical debt. In the first part of this, I want to talk about measuring technical debt. And what I want to do is I want to present a model for quantifying technical debt, not so that we can give each item of technical debt or each line of code a kind of precise, accurate to the cent cost, because that's clearly ridiculous. But I want to present a way of costing technical debt so that we can see the relative costs. This relative difference is important. I want to be able to surface the things that we need to fix that are costing us twice as much as the other items of technical debt that we've got. So I want to find the items of technical debt that are eating up the support time or impacting every new feature that we want to develop. So the first thing we need to be doing is recording our technical debt as we encounter it. So for our existing code, every time we find some technical debt, it should be recorded somewhere. And every time we deliberately introduce technical debt, we should also be recording that somewhere as well. This doesn't need to be anything too complex. It could just be a Word document, it could be a spreadsheet, or even Post-it notes if you really like. Whatever works for you. The main thing is it has to be recorded and written down, it has to be visible. Okay, and once we know what technical debt we've got, we then need to find a way to prioritise addressing it. And typically we want to try and avoid the big grand projects of let's improve technical debt in this part of the system all at once. It's almost like rewriting part of the system, the kind of big multi-week, multi-month projects you see that sometimes happen. And when this occurs, it's usually because you haven't been addressing technical debt as you go along, and it's got so bad that people feel a particular area of the system just isn't workable. It's too risky to work on. It's costing us too much to work on this part of the system. We want to avoid getting ourselves into that situation by addressing technical debt over time, and a key part of being able to do that is to prioritise it, as we said before. So the aim of our model is to break down our ongoing costs due to technical debt, our interest payments if you like, sticking with the debt metaphor. So this interest, it can fall into two different categories. The first is an ongoing cost. What I mean by this is these are costs that we're incurring right now without performing any extra development. This is where the technical debt that's present in our system is causing defects and issues that customers are having to work around. Customers are encountering these issues. And these are the issues that support staff are having to feel calls on every single day. So with no development work going on, this technical debt is costing the business. The second type of cost, second type of interest relating to technical debt is that what I'm calling a change tax. So these are costs that we incur when we do new feature development or make other changes to the system. And this could be extra time and cost in the analysis and implementation due to increased complexities, or perhaps it could be extra time needed to test due to the increased risk when implementing new features. So what we want to do is we want to be able to create a model, as I say, to judge relative cost, relative impact of different pieces of technical debt. And looking at our ongoing costs due to defects and issues, we want to be able to associate rough financial costs, roughly work out how much is this costing us each day or each month. We can do this by estimating the average amount of time spent by various people on these issues. We can then take that estimate and multiply it by a cost associated with that role. So let's look at the calculation for this. So what we want to do is that for each specific issue, so take each issue that's commonly cropping up, and on an issue by issue basis, how many times do customers encounter this each month? Work out who is involved in responding and dealing with this particular issue. So what we can then do is create a calculation based on the people involved and their costs and the amount of time they're spending. So for example, let's say we've got an issue, happens 25 times a month. We have first line support staff involved. Typically takes them an hour for each occurrence to liaise with the customer, verify it really is this particular issue, etc. So the cost for their time, and I've just used industry average salaries just from website. For instance, you don't have to get down to specific people having different salaries. This is just a relative cost, not a precise cost, as we said before. It just allows us to compare things relative to each other. Okay, so it happens 25 times a month, and first line support's about 1 hour on it. So total time, first line support per month is clearly 25 times 1, 25 hours. And let's also say that the developer time involved in this, they don't necessarily need to get involved in every occurrence, but perhaps now and again support need extra help from development to verify is this issue or to dig out some specific details relating to it, and this takes us 2 hours a month. So using the just industry average salary, so let's say $17.90 for a support staff, multiplied by the number of hours per month, 25, this gives us $447.50. Now, just a rough number, like I said before, we're not trying to be too precise with this, just using average salaries rather than specific costs that we've got, and just so we can get a consistent model that allows us to compare issues side by side. And developer cost, so let's say industry average salary hourly cost is $34 an hour, and it's 2 hours of developer time per month, so multiplying those together gives us rough cost on average of $68 per month. Developer time relating to this specific issue as it crops up. Okay, so adding those two totals together, this gives us a rough ongoing cost of $515.50 per month for this issue. These salaries are just taken from payscale.com. As I say, industry average just allows us to compare relative issues side by side. Okay, so basically what we're saying is this particular type of technical debt in this part of the system, which is relating to these issue occurrences, is costing us about $500 a month. Okay, if you do this for different issues in your system, you'll see that some are costing you more than others. So what I want to do now is the same kind of thing for our change tax, our new feature work. So how would we model this calculation? Okay, so what I want to do here, let's imagine a hypothetical system with a lot of technical debt in one particular area of the system. Let's say it's part of the system responsible for running reports of some kind. Okay, we might have a calculation, a cost calculation that looks a little bit like this for every new report. So we can say for each new report that we want to create, let's basically look at the amount of time that each person, let's keep our model simple for now, say developers and testers, and we want to work out how much time they have to spend adding a new report, both with and without the technical debt. And hopefully for our estimates with technical debt, where the technical debt is still present, hopefully we've got some real world stats on this. So if this is a frequently changing area of the system, if we're continually adding new reports, then we can look at these and look at these past reports that we've added and work out how much time they've cost us, how much time we've spent on these reports. So let's say developer time with this technical debt on average for these reports is 4 hours. It takes us about half a day to do. And what we can then do as well is estimate, and this is an estimate because clearly we don't have a system without the technical debt at the moment, but what we'll do is that same calculation but work out roughly how long it would take us without the technical debt. Okay, so we know how long it takes us on average for existing reports with technical debt. On average it has been taking us 4 hours. So now we say, well, if this technical debt was fixed, that we feel is painful, is slowing us down, how long should it take us to write a report? Okay, let's say that's an hour. And we'll do the same thing for test. So let's say currently it takes us 3 hours to test. We feel like we've got to spend a lot of time testing it due to technical debt because perhaps reports can break other reports. So maybe there's a little bit of regression testing involved in there as well. And again, we're measuring that. So we've got existing reports that we've added, and on average it's taking us 3 hours of testing, and these are the kinds of things we're doing when we test it. And then we can do the same estimate. It is just an estimate. We can estimate the time it would take us if this technical debt wasn't present. So perhaps it's slightly less test time. Maybe we feel like, well, if we didn't have this technical debt, we wouldn't have to do quite so much regression testing and impact testing, because the chances of one report having an impact on another should be minimal. That shouldn't be happening anymore with this technical debt removed. Okay, so looking at those 2 times, looking at the 4 hours and the 1 hour for developer time, and the 3 hours and the 2 hours for the test time, look at the difference between those, and we can say that the extra developer time due to the technical debt is the difference between those 2 times. So it's the 4 hours that it currently takes us, the estimated 1 hour that it should take us, so it's 3 hours of development time that we should save if we fix this technical debt. Same thing for the test time, it's only a 1 hour difference between the 3 and the 2. And again, using our average salaries from PayScale, what we'll do is we'll work out the cost in dollars. So just multiplying that up, 3 hours, developer time difference, times $34 an hour, gives us $102. Test cost, again, tester using an industry average salary, $22 an hour. Only 1 hour difference between the 2 solutions, so just $22. Then summing those up, our total cost per report that we can directly attribute to the technical debt alone is $124. This isn't the total cost of implementing a report, this is just a total cost relating to the technical debt. So basically, if we didn't have the technical debt, we'd have a saving per report of $124. And again, we're not expecting this to be an absolute precise cost, we just want to use this figure as a way to compare our technical debt. So taking just our 2 examples that we've just talked about, we can see that our defect, our ongoing cost, is costing us around 4 times more than the technical debt associated with the report system when considering the business as a whole. And that's based on only 1 new report per month. Obviously, if we're creating more than 1 report a month, then our technical debt is going to be costing us more in this particular area per month. Now I realise you might want to take a little bit more time to read through that in detail and think about how it might apply to your systems. So feel free to download the worksheet that's associated with this lesson, where I run through this calculation again in a little bit more detail, and also give you some tools that you can use to calculate your own technical debt relating to specific issues that you've got or new feature work that you've got going on in your system. The key thing to remember is that it's not a precise cost, it's just a model to enable relative comparison. That is the purpose of this model that we're developing. Allow you to compare items of technical debt side by side to work out which ones are costing you more than others. Okay, so I'll leave it here for now. What I'd encourage you to do is download the worksheet associated with this lesson and work out what your technical debt model looks like.